Hello, dear students. In the previous episodes, we have already derived the Ka and Kb for weak acid and weak bases respectively. From that, we have derived their HN and OH concentrations respectively. In the previous episodes, I had asked you a question that if it is a weak acid, can we derive its OH concentration? And similarly, if it is a weak base, can we derive its H ion concentration? The answer to that question is yes, and for you I am going to perform it over here. See how it can be derived. First of all, we'll talk about weak acid. Yes, weak acid, any weak acid, acetic acid, benzoic acid, as we talked in the previous episode. For weak acid, we have already derived an equation. If you have not referred the previous episodes, please do. The H ion concentration for a weak acid is equal to under root of Ka into CO, where Ka is acid constant, or you can consider it as ionization constant for weak acid, and CO is concentration. Right? Now, we want to derive the OH ion concentration for the same weak acid. Now, to derive the OH ion concentration, we need to understand one thing fundamentally that we have again talked in our previous episode for self-ionization of water. Refer that. Okay. OH ion concentration into H ion concentration is always equal to Kw. That is what we have come across in our previous episode. Therefore, for OH ion concentration, what I'll do? I'll make it the subject of formula, so I'll write Kw upon concentration of H ion. Now, what is OH ion concentration? That is what we want to derive for a weak acid, that is any damn weak acid, fine. But that is OH ion. Now, we know that Kw is a water constant, or you can say ionic product of water, and its value is always fixed. What is that value? 1 into 10 raised to minus 14. That is what we have come across in our previous session. Now, what is H ion concentration? According to this theory, the previous theory, the H ion concentration is under root of KaCO. So, I'll substitute that H ion over here, and that will be 1 into 10 raised to minus 14 upon under root of KaCO, and that is nothing but the concentration of OH ion for a weak acid. So you can definitely derive the concentration of OH ion for a weak acid. Similarly, I also asked you for H ion concentration derivation for a weak base in the previous episode. I'll do it for you. Now, for a weak base, when a base is weak like aniline, amines, or any alkyl amines or hydrazines, we know that OH ion concentration for weak base is always equal to Kb into CO. That is what we have derived in our previous episodes. This is what we know. But for water, we know that Kw is concentration of H ion and concentration of OH ion. Therefore, for a weak base, if you want to get the concentration of OH ion, make H ion the subject of formula, and that is always equal to Kw upon concentration of OH ion. What is Kw? Kw is ionic product of water, and the experimental results have concluded that its value is always 1 into 10 raised to minus 14 upon the concentration of OH ion. What is the concentration of OH ion? That is already derived. That is nothing but Kb into CO. And therefore I can say that yes, we can definitely derive H ion concentration for a weak base. Even though it's a base, its H ion concentration can be derived, right? So that was a simple theory that we should have considered for ionic product of water and merged it for the Kb, that is ionic product for a weak base, or you can say ionization constant for a weak base. For acid it's Ka, for acid it's Kb, and then we would have come to this type of conclusion, right? So prepare well, get yourself thorough with the topic, Till then, see you for the next episodes, next topic. Meanwhile, you keep in mind Saurin.S.Mehta chemistry. Subscribe so that more upcoming videos you get into it. And my email is tyrin1411@gmail.com for any further queries or questions. Till then, goodbye. Do take care of yourself. See you.